This is an example of a one sample t-test and confidence interval. This will probably be the first example that I do in class. But if you miss class or you just want to go over it again, here's the video. So what we have is we have a machine that is supposed to dispense, a coffee machine, supposed to dispense 10 ounces of coffee for each cup. But we suspect that maybe it's actually dispensing less. So the customers might be getting less than what they actually pay for. So it looks like they've taken a random sample of 20 cups. So we have to assume that that means that it was truly random. It wasn't just one cup after another. Maybe they did it at different times of the day, and maybe multiple days, something like that. Anyway, we want to know. So here, the first question: what do we want to prove? Well, we want to. It's right here. Is there evidence that the machine is shortchanging customers? So less than. So our null hypotheses would be something like 10 ounces. We're going to assume that it's working properly, and then we want to prove that, or we're going to try to prove, to see if there's evidence that it's actually less than 10 ounces. I guess we could say OZ somewhere. OZ. Okay, so let's see, we would say the machine dispenses let's say 10 ounces of coffee per cup. That's what we're going to assume. We're going to assume this is true and see if it leads to a contradiction. Okay, so then here we would say the machine dispenses, so I, less than 10 ounces of coffee per cup. Okay, so those are our hypotheses. Now we have a sample size of 20. Okay, and then our sample mean, what I would have to do is I have to put all of this data into L1 in your calculator. So 9.9, 9.7, all the way down to 9.9. And then you could do one variable stats and give it L1, and then you could find X bar, and we'd also want SX. Okay, so when I did that, let's see, I got 9.845, and let's see, I got a standard deviation of 0.199. Okay, so this is our what we got from this sample data. Okay, so before we can just use the normal model, we have to check these conditions. So a random sample, so yes, we have a random sample of 20. Okay, so our sample size is 20. The 10% condition, so I guess we would say 20 cups is less than 10% of all the cups of coffee the machine dispenses. Okay, so looking good so far. Now, what we're going to also assume, I didn't put it in here, but that from each cup of coffee is independent of the other, which I think we get if it's random and the 10% condition applied. But now we need, our sample needs, especially given that we have such a small sample size, 20 is still reasonably small. So the question is, what does the sample distribution itself look like? Because we need to assume that the central limit theorem will apply. And so 20 isn't so large that we can just assume it's going to work. So what you would do is you would just use your calculator to create a histogram of this data. So you just use stat plot, and I did one. Let's see. So let's see if I can draw it. I have about 2 samples that start at 9.4, and then I go to 9.8, and then I'm just using the trace function to get 4 samples. So that takes me over to what? 4 samples. Oh, that was 9.6. This is 9.6, so this is 9.8. 4 samples, and then the next one, it goes over the 10, and I have 8 samples, so I double it. So I had to play around with my calculator just a little bit. 10.0, and then the next one is 5, so just a little bit above. So this would be 10.2, and then 1 over to 10.4. So 10.4. So I played around with the window command to get this, but as you can see, the histogram looks. The histogram of the sample is nearly normal. So the central limit theorem also gives us some confidence that the sample distribution of the sample means, if we sampled over and over again and we got a bunch of sample means and did a histogram of them, so here we only get 1, okay, it would look like a normal distribution. Okay, so the conditions for inference are met, so we will proceed with a student's T model with n-1, so 20 minus 1 degrees of freedom to perform a 1 sample t-test, and then we are specifying an alpha level of 0.05. Okay, so this is our transition statement. Okay, so now we're ready to do the computations. So for the model, we'll have a mean of 10.0. So we're saying that the center is what we hypothesize. So we're going to assume the null hypothesis is true. Okay, so we have a center at 10.0 ounces. So now the standard deviation was, what was it? Right here, 0.199. So we're going to have 0.199 divided by the square root of 20. And let's see, I'll just have to do that real quick. So 0.199 divided by the square root of 20. And so I get 0.044. And I'm trying to recommend that you take it out at least 3 decimal places. Okay, so what that says is that this distance, 1 standard deviation away, is 0.044. 0.044. That's the size of our standard deviation right here in ounces. Okay, so now if we want to calculate the t-value, we want to see how far away it is, then we would take the observed value, which was, the observed value was 9.845. That's the average of all of these values here. So 9.845. 9.845 minus the hypothesized value of 10, and then we're going to divide by 0.044. Okay, and that comes out to be negative 3.49, which is sufficient. So we're going to go 1, 2, 3, and then halfway again, right? So about right there is our sample of 9.845, and on the t model it's negative 3.4 standard deviations. So that looks pretty significant. More than 3 standard deviations away from the mean seems significant. So if we wanted to know what's the area under the curve, it's not going to be very much, right? So we want to know what's the probability that our sample statistic is less than 9.845. That's how we read this, the probability. So that's the same as asking what's the probability of t less than 3.49. That's a 4. Okay, so now we want to know the area, so we're going to go from negative infinity to our t values. So this would be negative 9.999 to negative 3.49. And then right here what we do is we put in degrees of freedom. This is different because now we're using t-CDF, and we have to tell it which model we're using. And so the degrees of freedom is 19, and minus the sample size minus 1. Okay, and that comes out to be 0.0012. Okay, so that's pretty small. Okay, so since the p-value of 0.0012 is small, less than the alpha level of 0.05, we reject the null hypotheses. There is evidence that, and now I put all this work into my alternative, I might as well use it, that the machine dispenses less than 10 ounces of coffee per cup. That the machine, come on, something's wrong with my pen. Dispenses less than 10 ounces of coffee per cup. I guess on average, okay? So, or another way of saying it is that the mean amount dispensed by the machine is less than 10 ounces. Okay, so that's how you do a hypotheses test. So since, let's take a shot at this, since we know it's less than 10 ounces, but that doesn't really help us. The question is, what do you think the true, maybe we could do a confidence interval. What do you think the true amount is that it does dispense? And so what we would do there is we'd want to do a confidence interval. So let's see. The conditions are still satisfied. So we want to do a 95% confidence interval. So to estimate the mean or average amount of coffee the machine dispenses in a cup, we will use a student's T interval at the 95% confidence level. Okay, we first find the critical value. So if you know, it's the same thing for Z, just have to be a little bit more careful. So we have 0.95, so this is going to be half is going to be on one tail and half over here, so this is 0.025. And why do I have 2.9? That doesn't make sense right there. I think this should be 2.00, so just 2. So I'm going to take that and divide it by 2. So the calculator function you can use is inverse T. So what we would say is, well, we would just say that, and what we're going to get is 2.093. I'm not sure. Inverse T, I think you may also have to put in the degrees of freedom. It might be this command, and it may be that you have to do inverse T and you do 0.025 and then you say 19. I'm going to check that real quick just while we're talking. Second distribute, inverse T, and I think I give it 0.025 comma 19. Yes, so that's how you do it. So this is a little bit misleading right here. You have to do these. Now if you can't, if you have a TI-83, you may not have that function, so there's a way to look it up in the table in the back of your book at Appendix 80. Okay, so all we've done here is we've, instead of Z star for proportions, we now have T star, and we use that right here. So the margin of error, instead of Z star, we're going to use T star. So we have 2.093, and then the standard deviation we already calculated. That's going to be what was our standard deviation? I think it was 0.199 divided by the square root of 20. Okay, let's see, where did we compute that? Here it is, 0.044. Okay, so 0.044, and that comes out to be 2.093 times 0.044. So I get 0.092. Okay, so what we're going to do is our confidence interval is going to be our observed value, which is now a mean, and we're going to subtract. So I think the mean, it was 9.845, and we subtract 0.092 and we add 0.092. Okay, and I get, let's see, what do I get? I get 9.75 to 9.94. Okay, so we are 95% confident that the machine dispenses an average or on average of between 9.75 ounces and 9.94 ounces of coffee per cup. This result's consistent because it's less than the hypothesized value. Okay, so up here on our model, here's the hypothesized, so that confidence interval does not come out and include 10. It's the highest value is much lower than 10. So that confirms that the hypothesized value is not in there. So this is because the hypothesized value, so P0 equals 10.0, is above the confidence interval. Okay, so it's a long video, I understand, and I skipped over a few things. Some of the rough areas might be using the calculator, because I haven't shown you how to use the calculator, but you got to use the calculator here to get the p-value. You've got to use the calculator to create the histogram, and you have to use the calculator, probably you have to use the calculator to come up with the mean of 9.845 and the original standard deviation of 0.199 of the sample. Okay, good luck.